Video is going to deal with different ways of building a fuselage. And we're going to start this off with a little discussion of this airplane. This is the Sidewinder. Now the reason we're starting with the Sidewinder, maybe you've watched the Sidewinder construction videos. You'll know I made this plane for the 1990 Nationals. And it was basically a test airplane, a prototype. Featured a lot of unusual construction features, especially in the nose of the airplane. And several of them turned out to be usable, several of them turned out to be unusable, and we want to start with a little look at how this airplane developed over the years and some of the things that worked on it and added to our knowledge of nose construction, and some of the things that obviously didn't work. Now, if you recall, if you've checked out the Sidewinder construction videos, you'll remember that this plane was originally built to test and use the 40 size engines and 46 engines, and we originally started off using rubber motor mounts, rubber biscuit motor mounts. It's also good to remember that when you build a prototype plane like this, you expect a certain amount of things to need to be modified later on in the program. At the time we built this plane, we were trying to use a whole new power package, a tuned pipe, different types of gas tanks, and we wanted to have the plane as versatile as possible. Thus the reason that so much of the nose was removable, so we could put different engines in at various times right at the field. Again, the Sidewinder construction video shows a lot of that. Another thing that you might want to check out if you're interested is the tuned pipe development video. Shows a lot of the basic changes that were made to this and the other planes as we changed from various motors and muffling systems, various pipes. Now, I guess the most significant thing of all with this airplane that we learned was that we were not happy with the way the radial rubber mount worked at all. Any attempt we made to run the VMAX, the 46 on rubber mounts, was always less usable than when we had it rigidly mounted. And what we had was little rubber biscuits that we could replace with aluminum biscuits, so that right at the field we could change it from being a rubber mounted plane to a rigidly mounted plane. Later on, we went to the company that's in Nutley, New Jersey, that manufactures the rubber biscuits, and got some of all different hardnesses, and there was a direct relationship to how hard the biscuits were and how consistently the motor ran. The more rigid we made the motor, the better the motor ran, till ultimately we just replaced the whole front end with a glass nylon RC mount, got rid of the aluminum biscuits altogether, the rubber biscuits, and the VMAX and the Rossi, both of the engines that we tested in here. We also did some testing on a side exhaust OPS. All of those engines seemed to run the best and the most consistently when they were mounted rigidly. Now, one of the reasons motors run better when they're rigidly mounted is, first off, they make more power. Any absorption of vibration is a direct loss of power. And anybody that sells rubber mounts or uses rubber mounts is accepting the fact that they're going to get less total horsepower out of the motor. That's one of the downsides of using rubber mounts. So the first thing I want to mention in this video is we're not going to talk anymore about rubber mounts. I wanted to get this in on the beginning of the video because it's obviously one of the questions a lot of people will be asking, is why not just rubber mount the motor? Now, obviously some people have done that and been successful with it. And on the other side of that coin, there's some people that have been very unsuccessful. And one of the basic reasons is when you have any kind of an inherent vibration in the plane, it foams the fuel, ring life drops dramatically. Any engine that's vibrating, ring life is much less than what it is when an engine is rigidly mounted. In a way you can test if your construction needs to be improved is while the engine is running, reach your finger down and touch the glow plug, and if you feel it buzzing, you know you could use a little upgrade in your nose construction techniques. So I won't belabor the point anymore with the VMAX here, the Sidewinder, other than to say that any understanding of nose construction, any understanding of why we make the nose the way we do, and why once we find a successful system we want to stick with it. All of those things, the first thing we want to do is mention our failures, and obviously this airplane was one of the ones that, while maybe not considered a total failure, it did not live up to the expectations that I had for it. Again, it finished 7th at the Nationals in 1990. I'm sure it could have done a lot better if it had a little bit better motor run. The big problem was always the motor run being inconsistent, fuel consumption being inconsistent. Now, later on in the program, I guess you can notice that we've replaced the VMAX with an OPS side exhaust, then a Rossi side exhaust. Then we had OS Max 40s in here. Then we had, and finally mounted with a rigid glass nylon mount, a Big Jim Hemi 60, which ran better than all the other motors put together. The most consistent of all of them. And you might be able to see on the video this engine is running a custom-made tuned pipe that we're developing right now. One of the benefits of running a pipe is the engine runs in a much higher RPM range. In this case, this is coming off the ground at about 9,600, and the vibration is in a different RPM range. This particular plane and the way this pipe is set up, it cures a lot of the vibration that we normally have, but it's still not as good as having beam mounts. My overall opinion, and that's probably what you want to get out of this video, is that there is a good way to build a nose without making a plane excessively heavy. We're going to try to show that in several different planes that are under construction down in the shop. But be aware, there's one place you don't want to cheat the construction. From the leading edge of the wing forward, it should be rigid, it should be solid, it should be able to absorb the vibration and the torque of the motor. And almost every component in the airplane, the lifespan will go down dramatically when you have a vibration problem. Bell cranks will wear out, horns, wheel axles, controls, everything deteriorates. As soon as you get little cracks in the paint, the nose gets oil soaked. How many planes I've seen on the East Coast that the nose is literally falling off the plane? Not a pleasant sight. So we'll get on with some of the other things we learned over the years and try to pass as much of it on to you as we possibly can. We have some planes under construction, and we have some that are already finished we'd like to show. Now this is an engine mounting crutch. This is a method of mounting the engine that was developed, at least to my knowledge, by Big Jim Greenaway. Big Jim Greenaway, by the way, did most of the, I guess education is the right word, of explaining to me just how important a lot of these things are. Nose construction being, of course, the most important thing in the whole plane. If you have an airplane, and I don't care how well built the rest of the airplane is, and the nose is loose, you're going to eventually get little cracks in where the oil can get in, especially if it's not a tuned pipe plane. If it's a normally aspirated engine, it's going to get oil all over everything, and that nose gets virtually unrepairable after 100 or so flights due to the fact everything gets oil soaked. Then that perfectly trimmed plane that you spent all winter building and buffing and sanding and doing whatever turns into an absolutely useless piece of junk. Motor runs get more and more inconsistent, ring life goes down a tube, all the other parts of the plane deteriorate, and we know lots of people that have planes that last about 3 months. Sometimes they don't even make it to the Nationals, and then it's back to the drawing boards to build 6 more of them. If you build a plane properly, it'll last 10 years. I have 9 and 10-year-old planes here that fly every weekend. They're built properly. You don't cheat the nose construction. Now, what's significant in this, later on in the video, maybe we'll try to show how to assemble one of these. This is a part you can actually buy from ProStun Products. It costs $50. Seems like a lot of money, but then you consider you get a pair of matched motor mounts They're longer than the motor mounts commercially available that are 12 inches and aren't long enough for a typical 60 ship. There's hardened anodized aluminum pads, blind nuts. The alignment is done on a fixture, on a glass table. It's absolutely true in every dimension, and you have a variable amount of motor offset. You'll also see the little curve in the nose so that you don't get a lot of the motor mounts sticking out through the balsa wood when you go to carve in the nose. All nice little touches, by the way. This one is made for a Super Tiger 60, but of course it can be made for any motor. Again, the point to be made here is if you're going to use a Super Tiger 46 or a 60 motor that's going to run in a traditional mode without a tuned pipe, you want the nose to be as rigid as possible, tank to be mounted firmly and as rigidly as possible. And this is just one very successful way of doing that with the V-deflector system developed by Jim Greenaway. Obviously, there's other ways to do it, but this is one way that absolutely will help you if you can't figure out from plans or magazine articles how to build a proper fuselage. This information will be invaluable to you. And when you have an engine that you can't get reliable needle valve adjustments or the fuel consumption changes from flight to flight, ring life is short, bolts always need to be loosened up, glow plugs deteriorate, a million other maladies. Once you get your nose construction straightened out, those problems will go away or at least get 100% better. Now here's a completed fuselage. It's in the shop. This is one that's about ready, I guess, to have the top block pulled off and hollowed out. Again, this is the Jim Greenaway V-deflector system. It pretty much, if you stick with the program of 16th plywood doublers, in the case of a 60 half-inch square mounts, aluminum pads, and the V-deflector nose construction that's on the cardinal plans, pattern master plans, pretty much guarantees you'll have a decent motor run, good engine cooling, and the lifespan of the plane will be infinite, not limited by how much the plane shakes itself apart. This ship has a Super Tiger 40 in it. It has the typical cooling holes that are typical of a Jim Greenaway construction. You can see right in. You can see how much cooling area there is available right behind the engine. You can see the aluminum pads under the engine, the aluminum pad sets. This is a Jim Greenaway reworked 40. In this case, we have more than the normal amount of engine offset built in. When we build a 60, we build a little bit less. We build about 2 degrees into a 60, 3 or 4 degrees into a 40 or a 46, like a lot of motor offset. In this case, we have one of the Russian spinners that's being carved right into the top block. 16th plywood doublers. This type of construction, notice that the grain goes side to side on the nose. The bottom of the body, it should go on a 30-degree angle. A flat bottom of the body is much more rigid than a block. All little tips that'll help you build a better nose, better fuselage. In this case, we have the block pretty much ready for hollowing. I guess we'll put a canopy on here soon. It has a typical windy cardinal type of cowling. A lot of these details are on the cardinal plans, a good investment for $10. Steve Busso set of plans, accurately drawn. A lot of views of things and shapes and outlines, reference dimensions that you can use in building your own plane. Again, this is just one way. It's a very successful way. Almost every plane I've ever seen that's built this way has an extremely long lifespan, reliable engine run, good engine cooling, and very low vibration levels. When you design up a tuned pipe system, there's usually a little bit less vibration. but you certainly don't discount it altogether and just ignore it. Even on the planes that I'm running at 10,000 and 10,500, the high RPM 40s and 46s, you certainly, the more rigidly you can mount the motor, the better, and the longer everything will last. Now this is an experimental crutch that I'm going to be making up. Maybe we can show some of this further on in the video. These are 5/8 by 1/2 inch mounts, and the reason I'm mentioning this, they've been channeled out on a mill. Okay, the reason I'm mentioning this is somewhere, I don't remember if it was in a stunt news or wherever, they showed an idea of taking normal motor mounts and cutting this piece out for a piece of aluminum. But if you start with 1/2 inch mounts, you're going to wind up with a 3/8 dimension here. It's not going to be very reliable. You really want to have the full 1/2 inch here. When you start with 5/8, you'll always wind up with 1/2 inch square at the end. And if you're going to do this kind of a thing, at least start with 5/8 by 1/2 inch mounts, and you probably won't have a problem. These are special motor mounts that I've made up. Certainly when you do things like this, you have to consider it to be an experimental thing. This is not proven. This is experimental. This is an airplane that has a big Jim Greenaway nose construction, has the aluminum pads under the motor, a little bit different cooling outlets. This has tubing cooling outlets. This plane was made in 1988, the winter of '88. According to my logs, it's had about 160 gallons of fuel run through it already. You can figure out how many flights that is. We use this in several different modes. First off, this was originally made as a plane to run a barrel or a tongue muffler. We ran it that way for a full season. We ran it with experimental 40s and 46s for a half a season. Not much luck there. This plane is a little bit too large to be run by a small displacement motor. And then went back to using the Tune Pipe 60 that we've been real lucky and real I guess successful with. Wound up almost having a no-hitter with the contest seasons this year, and got second at the Nationals. Certainly don't want to put this guy to sleep yet, but there's a lot of things that are significant about the construction of this plane. It has the typical cardinal cowling. You can see after how many hundreds and hundreds of flights, it's as tight as a drum. This plane, of course, is the one that's in the Garden State Circle Burner video that was hit with an old-time stunt plane. Had the gear knocked out of the wing, the tail broken, a lot of the paper ripped, the flap broke. It's been repaired and refinished. It just gives you some idea of the durability. Even through all of that and through all of the years of running it without a tune pipe, it's still rock solid, absolutely rock solid motor runs. Motors last almost indefinitely in this plane. You don't have the problem of wearing rings out constantly like you do when you have a vibration problem. The plane is absolutely reliable as far as setting the needle, running different kinds of fuel. Just a good all-around plane. This is one that we can copy in the new plane. We're going to be building a 91 plane soon. We want to copy as much of the construction off this as we possibly can. Now, one of the minor changes we made on this plane over the years is, this is one of the motors Big Jim made up for me for experimenting with. This has a bell head, not a Hemi head. And one of the problems I encountered with running the bell head motor, when it was in this aeroplane, the OS Max needle was not fine enough of an adjustment, and I had to use a Tiger needle. Every other plane winds up using a Max needle, though. I would say probably the reason for that is the bell head is not as good a choice as a Hemi head. If you have a choice, when you get a motor from Greenaway or from whoever, get a Hemi head. Forget about squish band heads and forget about the bell head. The Hemi head is always the more reliable. Again, with a Hemi head, you get a much more torque than with a stock motor. A little less total power, but a lot more torque and a lot more flexibility. And very important that you have the nose construction figured out before you go and put that into an airplane. If you put a Hemi head engine into a plane that doesn't have 16th doublers and solid mounts, you might have a problem with motor runs. Keep in mind that the answer that you're going to hear over and over in this video is always, if you do things a certain way, you know they'll work. When you do things in an experimental way, well, maybe they will, maybe they won't. It's an important concept to understand. This airplane was built right off the Cardinal plans, the original plans. I knew every minute of the time I was building it, this airplane would have a long life and a consistent motor run. Had I decided to build this with rubber mounts, a firewall mount, mounts with holes drilled in them, mounts with channels milled in them, anything like that, I'd be running the risk. And maybe I would have built this is a built-up plane, by the way, did all the buffing and sanding and polishing and spent a year trimming it out, and it would not have been a consistent airplane. When I spend that much time and effort, I like to know that my results are going to be predictable and I'm going to get my money back come contest time. Again, because we're running this airplane at a higher RPM, this one flies at about 9,500. Because we're running a tune pipe, lower pitch props, Brian Ether big 3-bladed props, because we're doing that, we're in a different RPM range, but the nose construction still has to be rigid. We still can't resort to things like drilling holes in the motor mounts, having the tank in loose, having anything but 6/32 bolts and aluminum pads holding the engine in. It's not a good way to cheat the system. Now, before we actually get down to the shop and start doing some work with wood, I want to mention one other thing. The plane was built in 1986. This plane was third at the 87 Nats in Lincoln. Of course, it's had many modifications, a lot of them to the nose construction. This is one of the planes I built with experimental type nose construction that did not work out. And I wound up having to do a lot of re-engineering after the plane had a couple of hundred flights on it. And boy, was it a pain in the neck. I had to install aluminum braces up by the engine. I had to do several things where, as far as cooling was concerned, drilling extra holes in. I just didn't follow the plan that I knew would work, and I paid the price. And keep in mind, a lot of the knowledge that I have, I don't make any claim to be some kind of a super engineer or anything. I would leave those kind of things to Jim Greenaway, who has an awful lot of book learning on these subjects, but I certainly have learned to follow a consistent program and not get too creative when it comes to constructing the nose of the airplane. And one of the things I want to mention right up front, this plane did not have adequate cooling. This is a retrofit. This big dolphin hole did not have adequate cooling. The intake was too big and the air outlet was too small. You really have to pay attention when it comes to cooling. Cooling is a significant part of nose construction. The V deflector is the best way I know of to get adequate cooling. The V deflector system always puts more cooling air in there than you need. You're always on the safe side, even in 90-degree weather, and you really can build with some confidence when you use that system that you're not going to have to, like I did with this airplane, go back and re-engineer the whole plane 6 months or a year after you build it and buff it out. Again, if you take a close look at this plane is one of the primary planes on the tune pipe development video. You're going to notice, no cooling holes in the side. He got real creative. Nice big hole in the front, not enough holes in the side. wound up paying the price, wound up gouging things out, adding plywood later on, cutting holes in things after they already had a certain amount of oil on them. This plane in 1987, though, keep in mind, was one of the original planes that was made to use a tune pipe, so it had a completely removable belly. This plane won the Jack Sheik's Innovative Award. Since then, it's had the removable belly put in the garbage, and the tune pipe is sitting out in midair. Found that to be a little bit more reliable in this case anyway. But again, the most important thing to learn from this plane, keep in mind what we're trying to do with this is show you that there's a lot of lessons to be learned in nose construction. Nose construction is not something you sit down at a sketchbook, draw up a big giant cowling that drops off the plane. You want to keep the cowling as small. This plane has no cowling at all, in fact. Making the cowling big is a big mistake. Not using 16th plywood, even bigger mistake. Not using half-inch mounts on a 60, the ultimate mistake. And not using aluminum pads under the motor. Almost guaranteed that you'll have a problem, or you'll have a very short life for that airplane. And you can see in this view just how many holes and how big I had to make things. There's even a hole right here on the side of the tune pipe that I put in right at the field. I was so frustrated. Again, this plane has just the ultimate amount of flights on it. I don't think there's anybody on the East Coast that hasn't flown this plane at least 10 times. Been flown in contests, been flown in the rain, been crashed several times, had the gear knocked out of it, several other maladies. Still a rock-solid performer, still capable of winning contests whenever necessary. Mostly due to the nose construction. The construction of the nose, had the nose been done with 30-second doublers, 3/8 mounts, some kind of cheating system, plane would be an ounce or two lighter. It would have fallen apart 4 years ago. And obviously Big Jim Hemi, Big Jim tank. Tune pipe system. This guy runs at about 9,500 too. We have the prop pitched for 9,500. These are all big Brian Ether props. Another thing too, you may or may not find out, with a 3-bladed prop you will get a little bit less vibration. There's some airplanes that even though they're already built and they have a vibration problem, a 3-bladed prop will cure some of it, some of the time. Those are those nice Russian spinners that are available from Pro-Stun products too. So what's the point here? The point is, from every plane we build, and I build 12 to 15 planes a year for customers, and usually at least 2 for myself. By building so many planes in so many various ways, we've come up with a system that absolutely guarantees a consistent motor run. It's the system that's been developed and implemented on the original pattern master plans available from Big Jim, or cardinal plans available from me. The only difference in the 2 planes is the fuselage shape. Again, each plane we build, there's lessons to be learned. And that's the purpose of this. Before we go down to the shop and start chopping wood, what is the purpose of building this nose? The nose, to transmit the torque into the wing, give a good long life to the plane, obviously give consistent needle settings, not foam the fuel, not wear out the ring prematurely, not wear out the aeroplane prematurely. A lot of thought has to go into it. It's not a random thing. This is the last plane we're going to be discussing now for a while. Again, I just want to bring out the point. This is probably my, bring out some points here. This is probably my favorite plane of all time. Big Jim Greenaway and myself spent 4 weeks working on the wing templates for this plane. You can see it's a 4-part wing. Very complex building. It's a semi-scale of a Reno Air Racer. It's got some molded fuselage parts, full cockpit, whatever. None of that, however, is important as the nose construction. The nose construction on this plane has 5/8 mounts by 1/2 inch, 16th doublers, a big hood scoop, some fake exhausts, But one thing about this plane, it has withstood the test of time excellently. This plane has been flown in a lot of local contests, flew in the '89 Nats. We got 4th place. I don't know what the deal was. I thought it should have done a lot better than 4th. And half of the judges that judged came over and told me I should have won. So it proves that they don't know what they're doing. That was the year Bob Whiteley won the concourse with the laser. 2 semi-scale planes were in the front row. This was probably the runner-up plane. I was real happy with this plane as a flying plane. And one of the things I always liked about it was so consistent to get the needle set. This was not a test plane. This was a plane that was built to print. Has a V deflector in it. Has all proven technology, and that's the way I want to close this out. This is not an experimental plane. This is a plane that was built strictly with proven things that we knew would work. Since '89, it's been flown a few hundred times. We've used it to test tune pipes and various new motor combinations that Jim has come up with. Right now we have on an anodized homemade header, one of Dave Midgley's custom tuned pipes for a 60. But I just want to reiterate, this is a plane that's made to print. It has no experimental parts. It's lasted hundreds and hundreds of flights without even a crack in the paint. It did well in national competition. It did even better in local competition. It's dead reliable. And this is what we're striving for. From this video, what I hope you'll get out of it is to build things with proven, reliable parts, without experimental parts. And if you get that from this video, it would be well worth the time and energy to watch it. And pass it on to your friends, please. Pass all of the videos on. Trying to get this information out to people. We're in a very small hobby. It's very hard to get information from reliable sources. Magazines are limited by how small their articles are. People that want to know this stuff, really need every avenue they possibly can to get it. Alright, we're down in the shop. One of the things I want to mention here is when we do a development program, like we've done on these 60 ships since 1983, one of the things we always wind up doing is keeping a 16th plywood template of every fuselage side, every motor mount height, the wing cutouts. We save the templates, of course, for the wing, the rudder shapes, whatnot and whatnot. Now, the purpose of keeping all these things, we even have a template for the cowling here and the landing gear mount, so all the planes have interchangeable gear. The purpose of doing this, so we know from year to year that we're not making changes to the plane that'll add an element of unreliability. We certainly recommend every plane you build, regardless of the motor, even if it has Fox 35, that it has 16th plywood doublers. We've built some that go all the way back to the end of the wing, like this one. We've built some with holes in them, some short ones, some long ones with holes. What's most important is that it's 16th plywood. If you're really weight conscious and you want to cut these little holes out, don't overdo it. You're not going to save that much weight. When it comes to rudder shapes, we found a certain size rudder that for a 60 ship works well. Too big of a rudder and you always get weather vaning. Too small of a rudder, of course, you know, the performance deteriorates and you get a lot of GP from running big props. That's the idea of a development program, is to constantly monitor what you're doing, try to refine it piece by piece. And the ultimate refinement, after all this work, in 1989, after all this development, we came up with the Cardinal plans. Now, the Cardinal plans were drawn by Steve Busso. This is the wing part here. I keep a set right in my office, laid out for reference constantly. The Cardinal proved to be the most reliable airplane. had the best construction, came out the lightest, could be made in foam or built up. Absolutely worth all the effort of drawing these plans up, putting all the things on them, all the details. There's 2 sheets to these plans. But this is the Bible. This is the core of everything we build, and this is our reference. We don't try to cheat the nose construction. We certainly don't ever try to cheat the control system. Arrow shafts, 4-inch bell cranks, 1/8-inch horns. Now you have a plane that's reliable. It'll fly in a wind. The bushings won't wear out in the controls. You'll have thousands of flights. But again, it's from a development program. That's the other point I want to make here. It's not from the first time Joe Blow sits down at a drawing board and decides he's going to build an airplane. It's from a constant evolution of things, constant evolution of changing and going back to the original, seeing how long things last and how well they performed. And if you're just starting a development program, if this is the beginning of your development program, keep track of it. Keep templates of everything you do. Or else you can just leave the work to people like Jim Greenaway, who do this same thing. Constantly monitor, make small changes, evaluate whether they're good or bad. And so when you buy a set of plans from Big Jim or from myself, you know that that plane's been developed over the years. It's not an experimental design. It's not something you're going to be disappointed with after you spend all that time building. A development program is a very important part of nose construction. Let's get some of the things that we need to know about. 60 fuselage. Going to make a fuselage for a Super Tiger 60, which is probably the most common motor right now. 1/2-inch by 1/2-inch mounts. Absolutely important. Aluminum pads under the motor. Anybody that doesn't know what an aluminum pad looks like, these are available from ProStun Products, or you can make your own. They're made out of hardened 6061 aluminum, aircraft grade T6, anodized, polished. They're made with exactly the right holes for a Super Tiger 60 or whatever motor you decide you want. They're countersunk for little wood screws. They come in a pack with all the screws, nuts, and bolts. Best investment you'll ever make in the long life of a plane. Okay. Absolutely 2 important things. Third important thing, 16th ply doublers. Find some other way to save weight. Don't cheat the doublers. Gene Schaefer, absolutely one of the best flyers of all time, was always a fanatic for building light planes. Never, ever cheated the doublers. Any plane he built without the doublers immediately was a junk airplane. This is one. These are 3 things I can't emphasize enough. Can't emphasize enough on this. Small cowl. Don't make a cowling. If we got the nose of the plane here like such, don't make a cowling where half of the nose drops away, because all of this is doing nothing but going along for the ride. Most important, especially if you use a 60, a little tiny cowling. You can look on the cardinal plans again. Little tiny, the smaller the better. Plenty of cooling holes. Okay, important part. These are all important ideas to have in mind. When you decide you're going to design your own fuselage, which most people decide they want to improvise a little bit, they're not going to build right off the plans, whether they're Cardinal or Pattern Master or whatever. Keep these things in mind. Don't cheat these things. These are things you can cheat. Mounts to wing. The idea is to connect. If this is the wing, you want the motor mounts to run right back. That's why we sell extra long motor mounts. You don't want to have, what you don't want to have would be this, where the mount ends in front of the wing, whatever this shape is, and you've got a big gap. You don't want that gap. The mounts should be epoxied right into the top of the wing, hopefully. Don't get too carried away with these little drawings. We're going to show this all in real life later. These are concepts, though, that you want to have. If you want to make your airplanes last forever, they have to be built like airplanes, not like toys. You want to save weight. Every one of us wants to make the world's lightest plane. There's things you can lighten up. Use good wood. Okay, C-grain wood. Again, fuse sides, 1/8 inch minimum. C-grain. Anybody doesn't know what C-grain is, I don't know if we can show it on the video reliably. I guess we can't. You won't really see, but the grain of the wood looks like all pebbles. You can look in a SIG catalog and get an idea of just how the grain looks on C-grain. C-grain for sure. Fuse sides. Absolutely important. Straight wood. Not the world's lightest, but the world's straightest. So you don't have a fuselage that has all kind of pretzel bends in it eventually, or that the tail comes out crooked. All important things to remember when you're either designing or building the fuses. Keep all these concepts, keep all this information together. Remember I showed those mounts before that were relieved? Well, somewhere, I don't remember, in a magazine, somebody was showing that you have 1/2 inch, this is 1/2 inch wood, and you knock this out and put the aluminum in here. Well, you have a stress riser right here. Right here you've defeated the whole purpose of having 1/2 inch mounts. Another thing, if you're going to do this, make 5/8 mounts like I showed before, and then relieve them an 1/8 of an inch. Make them 5/8 by half. Okay, all important things to do. This is probably the world's dumbest thing to do, is take a motor mount and drill a whole bunch of holes in it. Because right here there's a stress riser. The rest of this mount you may as well not even put in the airplane. Right here where the first hole is where it ends. Almost guarantees you'll have a bad motor run, vibration problems, etc., etc. Ask anybody that's done this, they'll tell you. I don't want to name names on a video, but I'll give you a personal list of 10, 15 people that are sorry they did this, that's for sure, especially using a Tiger 60. Bad idea. Now you can go through a whole bunch of motor mounts. You can see I have hundreds of motor mounts here. These are cut by John Gajewski on a precision saw. They're match sets. They're joined. Let me make another point here. Another good point. I don't know if you're going to be able to see this. Maybe I ought to draw it out on a piece of paper. The end of the mounts. You have 1/2 inch square mounts. Okay. Important concept. When you want to maximize fuselage construction, you have the edge of the mount. Okay? And the grain is going this way. Grain is going that way. Okay? This is the way the bolt wants to go in. Like so. This is good. You do not want to have the mount with the grain this way. When you select your mounts, you want to get straight mounts. Straight, parallel, matched set. Now when John cuts these mounts, he cuts them up, and you probably can see this is just a small sample of what we have here in stock. There's a whole drawer of them down there somewhere. There's a whole drawer. You can look on the video catalog. It even has more information about motor mounts. Motor mounts are not a random thing you just buy from somebody. Use any size, use any two that you find. You select balsa wood, select the mounts. They should be straight, they should be matched, they should be parallel. And most of all, they should have the grain going the right way, the bolts. Very, very important. Now, if you buy a set of motor mount pads from ProStun Products, they come with the correct 632 bolts, blind nuts, washers, and lock washers. I don't use washers and lock washers unless I have to drill out the engine holes big enough to get offset in them. If you don't have to drill the engine out, the minimum amount of washers is the best. Every washer you add to the system is one extra clutch, like a little clutch plate that's going to tend to loosen up. Best system of all is to have none. Okay? Concept number 2. These are blind mounting bolts. 632 for a 60. Okay? I've seen several people try to use these. This is a maybe. This is one of the things that inserts into the wood. I could name several people on the East Coast. No sense embarrassing them now. They've had these things pull out in flight, pull out while they were launching a plane, motors come out while the plane was sitting on the ground. These are not a good idea. These might be useful on holding cowlings down, hatches, wingtip boxes. Not a good choice for holding motors and airplanes. Also, when you use these instead of aluminum pads, what happens is you lose your alignment. When you have the aluminum in there, you never lose the alignment. It's an important thing to understand when you're engineering up a body. I don't want to spend a lot of time on the video talking about profile planes, because profile bodies are not what this video is about. But if you do decide you're going to use a profile body, you can get this very inexpensive. These sell for $1.98. They have the offset built into one side. They're made out of glass nylon. They come in 2 different colors, so they coordinate with your plane, of course. This is 44% DuPont glass nylon, very durable. You glue this onto the body, hot stuff, then drill the motor right in. It has the correct offset. Again, a profile body will never be as good as a normal body, a built-up body, but if you're going to use a profile, absolutely positively use these offset pads. Very inexpensive, very durable, and they do a good job of absorbing and spreading out the load of engine vibration. Now we're going to do like a front view here of a motor mount crutch. Okay, we've got the wood filled in with the grain side to side. Okay, and let's assume this is your fuel tank. This is looking from the front, whatever kind of venting you have here. Okay, one thing I've noticed is when I shim this with balsa wood or even plywood, I shim the tank to get the correct needle height. After a certain amount of flights, the balsa wood tends to crush down. It picks up sharp spots on the tank. The tank moves, shifts a little bit, and you lose that exact needle setting where it's equal, upright, and inverted. One of the things we've done in the last year, Billy Suarez came up with this idea, is he came up with 10, 20, 20, yeah, God, I can spell, and 30,000 shim stock, plastic shim stock, that the tank slides in real nice, you can get it out real nice, and it doesn't crush down after 100 flights. I'm sure it's available commercially. It's just a very precision-made thin plastic, rather than using plywood and different things. Now this, because it comes in precision sizes, you can shim it 10, 20, or 30 thousandths very accurately, so that your 8s are equal, the motor's braking exactly where you want. Once you go to all this trouble of getting the crutch just right in the fuselage, you don't want to have the tank floating around. And you want to have the tank, obviously the tank is rigidly mounted as possible. In years gone by, I've done a lot of experimenting with plastic tanks, never got them to run as good as a metal tank. Other people use plastic tanks successfully. If you decide you want to use them, a good person to call is Dave Cook, Bob Hunt. These people have had relatively good luck using those tanks. I suggest using a metal tank, Taffender tank, Smith tank, and have it reworked by Big Jim with baffles, the correct kind of baffling, and all that time and effort you put into it will be well worth it the first day you're out on the field, and everybody else is having motor problems, and your thing is running fine. Now you have your 2-cycle part of the run, 4-cycle. When you have a vibration problem, you can't get the needle set correctly on the ground, so that's a problem right here. What's also a problem is you don't want to be over lean in the 2-cycle part of the pattern. And what happens when you get the needle set correctly on the ground, you start halfway through the flight getting air bubbles, and you're putting a milkshake into the plane, you're turning the fuel into a milkshake. The 2-cycle part goes overly lean, and you French fry engines. That's a very common thing. Nose construction eats engines. Poor nose construction will always result in very short life of engines. So, a lot of people, to compensate for this, when you've screwed up and you don't have this correct 2-cycle, 4-cycle transition, a lot of people have resorted to 12% nitro. Because of the wide needle setting of nitro, it kind of helps. Or they resort to using very small props. All these things will, be a stopgap, but you'll never be able to run the prop you want. You'll never be able to run the correct nitro to get the right power if you don't have the 2-cycle, 4-cycle part right, or if you're having a fuel foaming problem. And to check this, it's real easy. Check this anytime you want. Take the cowling off the plane, turn it upside down, start the engine, wait till half of the tank is used up, and look in the line between the fuel and the tank. And if you see bubbles going in here, no good. You have a fuel foaming problem. If you put your fingertip on the glow plug and it's shaking, you have a problem. You're never going to get those consistent motor runs. And when you don't have a consistent motor run, every time you come out of the wing over and pull out inverted, you don't know if it's going to shut off or if it's going to give you that old schnurly wow and you're gone. You'll never get that consistent pullouts, the consistent confidence in your flight on pullouts until you get the motor run right, until it's reliable and until it's the same every time. Very, very important and often overlooked even by expert flyers. So my exact step, now that you're going to do this body, I would do it in this fashion. Draw up a set of plans, the correct nose moment arm. Again, that can vary. If you tend to build heavy, make a long nose. If you tend to build light, make it short. Best thing, of course, is build from a set of plans that you know is a proven, reliable design. Pattern Master and Cardinal are just two examples of planes that I know are dead reliable. Moment arm has to be right. Plot that out. You want the height between the center line of the wing and the thrust line of the motor. And if you look on a Pattern Master or on a Cardinal, this has already been figured out for you. But this is a critical dimension. It's not a random thing. This critical dimension will give you the proper center of gravity, vertical center of gravity. Without that, the plane will always be top heavy or bottom heavy. Part of figuring this out will be knowing how high the tail is from the wing and how heavy the landing gear are going to be, landing gear and pants, if you're going to use wheel pants. All these things have to be calculated in to get the proper vertical CG. Again, the easiest way to do this is from proven plans. So let's say you start with, this is just an example now. You copy this off of a set of plans. Let's use the Cardinal for an example. And these are very rough drawings, obviously. If you're going to make your own design here, well, you might want to change the canopy shape a little bit, okay? And you might want to square off the rudder or whatever it is. And if you don't get too carried away, if you keep all these things close, you will not have a problem. But the things you should be very conscious of keeping is thrust line to the wing center line should be the same. Tail center line to wing center line should be the same. Gear height to the wing center line, the same. Once you plot out all these dimensions, well, you may decide you want to have some shape like this. You may want to have a different shaped rudder or whatever. But keeping all these critical dimensions that I mentioned in proportion will almost guarantee a good aeroplane. It's not important if you change the canopy. Some people like a different shaped canopy. That's the shape I like. Some people like this or whatever they like. Some people want to have a bubble canopy. But don't change the critical dimensions that make the plane a reliable performer when you design up your own fuselage. This is just one example of planes that have been built from Cardinal and Pattern Master plans very successfully. And certainly you should take advantage of all the information that's available if you're going to modify them. Try to stick with all the things that are important that I just mentioned and change the things that aren't important. The paint job, the canopy, maybe the scoop and the cowling or whatever. But don't change the things that are proven to work well. And that's why the plans have evolved over years and years of trial and error. Don't just reinvent that and scrap that part of it. Now this is Scott Smith's design. Steve Busso's design. I don't know who really gets the full credit for this. I think they worked on it jointly. This is one that was made by a fellow in Japan. Because he used the plans that were already proven, they've already been debugged, if that's the right word, came up with a very successful design on the first shot, was very happy with it. A lot of good construction techniques are on any plans that Steve Busso draws, and of course he did the Cardinal, the Cascade, the Kestrel. All reliable planes. The plans are accurate. They're not just drawn with a pencil and totally disregarding the accuracy factor. These are quality plans. People all around the world have built these planes and had success with them. This is Robbie Hunt. He's been one of the most successful people in the advanced class with this particular airplane. Now, this particular airplane had a rubber mount system and a Weber 28, and it required several re-engineering things to get it to work. After the plane was designed and flown, it had to be re-engineered. The nose construction was a typical problem. It's a typical problem I've had, and this is not a criticism of anybody that's had to do that. It's pointing out the fact that even if you build a plane and the construction is incorrect, you're going to have to go back and correct it later on. Bob Hunt at the team trials had some problems with cooling. He didn't have enough cooling holes in the plane. He had to go back right at the team trials and cut into the plane. Obviously, he got it working. He made his way onto the team. But the point of the video is, and I'm sure Bob would be the first one to tell you, it's a lot easier to do these things in the shop. And no matter how good of a flyer you are, and Robbie is certainly one of the best, and obviously Bob is a former world champion, no matter how much talent you have, it's easier if you don't handicap yourself. Right at the point you're building the body, think of these things ahead of time. Take advantage of the technology that people have already worked out. And again, if you were interested in plastic gas tanks or running the OPS engine, Bob would be your first choice. If you were interested in how the little Webers work, give Bob a call or Robbie. These are people that have worked extensively with these engines. If you're interested in the 60, well then my first choice would be Big Jim Greenaway, Tiger 46s, Max S's. I'd be going to the person who's had the most success with that particular thing that you wanted to use. Now here's an old plane that anybody that's seen the East Coast flying championships from '81 on, this plane was a very famous plane, a 900 square inch plane. This plane had 3/4 by 1/2 inch mounts, had a 10-ounce gas tank and a 14-inch nose moment arm, had to pull around 95 ounces, and yet because the motor was totally isolated from vibration, it ran as reliable as could be. The engine turned to 14.6. It was a special Big Jim Hemi. Absolutely perfect motor runs every flight. Never a problem. Even though the plane was that heavy, the wing could carry it, the nose construction was solid, this plane absolutely had a good motor run. The best of all possible worlds here is when you can have the motor run reliably, make the right amount of power, and have the wing big enough that the airplane's competitive. This is a picture of Chuck Holtzapfel, one of Chuck Holtzapfel's planes. Now Chuck knows from years and years of doing construction in various ways. He's made some pretty innovative foam wings with cap strips, some various built-up construction techniques. Pretty innovative guy, but I don't think Chuck has ever been caught cheating the nose construction. I think all his planes had a good running motor. So you can be really innovative and creative, but you really can't cheat that nose construction without running into the high-risk area. Now the guys in Japan, this is a picture of the Japanese stunt club. The fellows in Japan were so happy with the Cascade and with the drawings of the Cardinal that I sent them, various things that they've been experimenting with. Basically the nose construction was one of the areas that they all benefited from. I got many, many letters from the fellows in Japan saying how important it was and how valuable it was for them to understand how we get the good motor runs we do with the 60. Because most of these airplanes come apart for transportation. But there's several letters from these people. They've all been happy with the technology. They've all really benefited from the basic technology that's on this video. Anybody that's been around my shop since 1987, when the tune pipe program starts, knows how much time, energy, money, effort I've put into all kinds of tune pipe programs. Hundreds and hundreds of hours and thousands of dollars worth of prototypes, various setups, different things. And the object of all of it was to get the proper motor run, get the proper amount of power. All of the tune pipe engines have tremendous power, but if they're feeding up instead of a reliable fuel supply, they're eating a milkshake, you'll never get them to run right. They have some super benefits if you can get everything engineered up right, but believe me, if you build a tune pipe plane and you make a flimsy nose, you will not get the full advantage of using a tune pipe. You will always be one step behind. Jimmy Casale's Columbia won the Nats twice in a row. One of the reasons this plane was very successful, he has big strakes on the side of the fuselage, and even though Jimmy has built many planes with lightweight doublers and thin mounts, I'm sure one of the reasons this plane was one of the best of his was because it had a little bit better motor run than all the other ones that had the thin fuselage construction. And you know, Jimmy is a fanatic for keeping things light. There's certain areas on his planes that I'm sure are much lighter than mine, but I would not recommend some of the things that the light doublers, the thin mounts, you run into that high-risk area. And obviously Jimmy's had some planes that are very reliable, and this is one of them, and some of them that have been less reliable. You have to realize how much you want to take a risk when you spend all winter buffing out a plane. And if you can afford to spend the kind of time that Jimmy does, Jimmy builds 3-4 planes a year, well, you can run a high risk that some of them aren't going to run. If you only build 1 or 2 planes a year, they had better all be good ones, and there better not be any high-risk things involved. Now, speaking of high-risk things, this was an experimental plane we made with rubber mounts. Very lightweight nose construction, even though it had 16th plywood. After the plane was flown, we later gave the plane to John DeTavio, who flew it with a Super Tiger 46 for a whole season. And we had to go in, glue the tank in, glue in some extra plywood, glue in some extra material underneath the nose, beef up the nose, and glue the tank in. And it would have been a lot easier to do that right at the time we first built the plane. It would have been a lot more convenient. That's what I'm suggesting you do with this video, is do it right on the drawing board when the plane is new. Chris McMillan, the fellow in the back here, he built the plane with a unique nose construction, an experimental nose construction, and it didn't work out so well. He had to go back to rigidly mounting the engine. So we've all tried this stuff, and all we're trying to do is save you the time, effort, money, energy. If you haven't done it, learn from our mistakes. Every one of us that's on this video has something to add to that program. Now, as I mentioned before, there's certainly more than one approach, and I'm not trying to tell anybody out there that I have this single approach that, if you know, the only way in the world to do these things. There's several good ways to do these things. Dave Cook has a way of making a fuselage with a bottle tank, a round bottle tank. And again, if you decide that's what you'd like to try, well, he'd be my first choice. Give him a call. I'm sure he'll give you all of the best information that he has. He's been real successful in his group of people in New England running that system. I've been real successful running the metal tanks. If you want to know about metal tanks, you call Big Jim. If you want to know about the plastic tanks, my guess is Dave Cook, Bob Hunt, Bill Werwidge. Those would be the people that have the most time using that system. This is a ship that was made with the idea of keeping the nose as light and rigid as possible. You notice there's no cowling, there's no cutouts. The object of the whole thing was to keep the nose as light and rigid as possible. And by the way, this did work out well. This is the nose construction from Louisiana Lightning. Notice the big air outlet hole, a big square air outlet hole from the V deflector. No cowling at all, everything rigid. By the way, I don't personally ever glass the nose of the plane. I know some people do. I would rather put the weight and the time and the effort into the engineering of the plywood parts and the V deflector. That way has worked well for me. If you're prone to build a lighter construction and then glass it, then you might want to talk to somebody that's had success doing it that way. The best success I've had is doing it with wood. The equivalent amount of wood will always give you a reliable motor run. I think you're much better off all wood and tissue rather than the glass. One of the planes I always thought had a well-engineered nose section. Lou McFarland Shark. Nice small canopy. Nice rigid construction. Well-engineered plane. Gene Schaefer in one of his models. And you can say what you want about Gene Schaefer. Never was the world champion, never was a Nats winner. But you never talk to anybody. It's funny, it's unique how you never talk to anybody who, the minute the subject of who was the world's best flyer comes up, his name always gets mentioned. And I don't know that he didn't deserve to win some of those Nats. Maybe one of the things that held him back was his building. I don't know, but I certainly never talk to anybody that doesn't have something real positive to say about Gene. The reason I mentioned Gene was a fanatic about weight. He used to use string to hold the landing gear in instead of J-bolts because they were lighter. He did all kind of crazy things to make the planes light, but he never cheated the 16th plywood. That was the one thing he would never cheat, and probably one of the reasons he was so successful running all these various size planes and engine combinations. All right, step one of any good body is going to start with going through a pile of wood. In this case, we've weighed up each piece of wood. Here's a nice piece of sea grain, by the way, if you can see it. We're going to go through a stack of wood here and try to get two matched pieces, or pieces that have similar grain. Hopefully they're both going to be sea grain. But again, we're going to weigh all the wood, mark each piece, take the two lightest pieces that are sea grain, and start the building process. Well, you got some nice 1/4-inch pieces. Okay, all this wood is weighed up, and I notice we have some nice. This is a real nice piece of sea grain. Well, you got 2, 3, 4 pieces. You got enough to make 2 bodies here. Great. Don't even think about using the other ones. We want to use the sea grain. Yeah, put these away.
Two?
Yeah. No matter what, these are going to be the 4 used. Look at the grain on these, beautiful. Yeah. I try to get that on the camera. Now, Dave, this is Dave Midgley. He's working with me here. We're lucky enough to have 40-inch wide wood, 4-inch wide by 48. You can sight down it this way and see if you have. Looks like they're all pretty straight. Oh, you got nice wood here. This wood came from Lone Star Balsa, by the way. Give him a plug. And what we've already done, since Dave and I are building similar airplanes, we've already made a sketch of next year's plane, kind of an outline of what we want the plane to look like. And we're going to start working off this drawing and making up a sketch for the crutch. So that's really going to be the next step in the process here. And this looks like just a rough idea. These are both going to be cardinals, and we'll be working off just kind of a sketch here. The few changes we want to make to last year's plane. All right, this is a nice, oh, this is a real nice light block.
That was the lightest piece of wood on the planet last year.
This is your inboard tip. The one that's really soft and spongy you can use for the inboard tip. Obviously, that's going to be the one.
Those are heavy.
This one's a little heavier.
I get 2
This
of
can
them.
that can be an outboard tip. Again, all these are weighed up, and we'll take the lightest one for the top block, second lightest one for the inboard wingtip. So, without belaboring the point, it's important to weigh all your wood. Dave's got every piece of wood weighed here. The lightest piece is on top, and it goes down to the heaviest. We'll build off the top of the pile when we need formers. This the real good one? Oh, this will be for my plane.
No, feel these.
These two are better? And it's not significant if you have to put a joint in it. I'd rather have the light piece of wood and a joint in it. The joint can be in the back where you don't even see it. This one, oh my God, this one is great. This is like the one I made the Griffin out of. So, okay. Selecting up the lightest pieces of wood is going to be the first step in making up this body. And I guess we can do the rest of this wood selection off camera. Okay, now step one is we have the template. We've made a template of plywood right off the drawing that we're going to use, which in this case is a cardinal nose section with a cardinal cowl. Dave is tracing it out with a pen. Notice that he's not using a parallel edge. He wants the grain going corner to corner, 45-degree angle here. We don't want the grain going parallel to an edge. I know this wastes a lot of plywood. It means each double would probably cost you $1 or $2 more in plywood, but the amount you gain in strength is unbelievable this way. Now since Dave is using a foam wing, he's making an adjustment to the template from the pattern that he used last year. Last year, that's the pattern that he used. Now if you ever look at a piece of plywood, you'll see it has a lot of strength one way, almost no strength the other way. Normally people that are trying to save money will run the doubler even to the edge of the plywood. You'll get more doublers out on a given piece of wood, but you will lose a lot of strength that way, and you might incur a vibration problem. This is a way that almost guarantees you won't have that problem. And you should always work off plywood templates, that's for sure. When we're finished with these plywood templates, we want to kind of tack glue them together and make sure they're both mirror images exactly the same of each other.
Where else are we going to need plywood?
For right now, that's all you're going to need. Okay, now what Dave did when he rough cut out these doublers, he rough cut them out a little bit oversized, maybe the thickness of 2 or 3 pencil lines. And what we're going to do is tack glue them together right now. And we're going to go over to these sanding belts. Now these sanding belts, I don't know if you can see it, one is about 40 grit, one is 220 grit. These are belts that belong on a little belt sander. You can buy them in Sears Roebuck, about $4 a piece. And then you spray contact cement on the bottom of them, spray contact cement to your glass tabletop, and you've got a nice little thing for sanding down and getting a true edge on. And what this ensures is you're going to start with 2 mirror image, perfectly the same doublers. You don't want to have one doubler 1/4 of an inch longer, wider, thicker, thinner, whatever. 2 exactly the same. And you can see he left a little bit of wood on. We'll take the rest of it off with the belt sander. Then we'll make sure we have a top parallel edge, and we'll put a center line on both of them. Now you can see what that does. It gets a perfect parallel edge. You leave the plywood a little bit oversized. This is also good for truing up your fuselage sides, wing sheeting, you name it. Puts a perfectly true edge. Once it gets off to 40 grit, get onto the lighter sandpaper. Coming all right?
Yeah.
And it's so easy when you have them both glued together. A lot of times when I'm doing this, I'll make the crutch up first, the mounts and the wood, but in this case it's convenient to do it this way. We're getting the same amount of information on the video here. Looking good?
Beautiful.
You also get both of your cowl cutouts exactly the same then. When you shove a block in there, it'll line up perfectly. I always like to leave a little bit of extra clearance for the wing so the wing is floating in there, and shim it up with wood after I'm ready to align the wing and tail.
You'll want to move to New Hampshire permanently.
Now one of the things you can mention is, like, while we're doing one plane at a time, you can make up little component parts ahead of time. This is parts of what'll be my 1992 plane, the wing ribs, some extra hardwood blocks, some little landing gear blocks, landing gear clips that I made for wing gear. I made up my fuselage doublers the other day. They're already sanded out. They have the center line on them. And Dave will probably have, when he's finished, exact mirror images of these. So, but I've made up little parts ahead of time before I actually even start building. I make up all my little component parts. Then when it actually comes time to build, I really only have a very limited amount of time to build. And it's like putting a kit together, like putting a jigsaw together. Remember, he's got both of these doublers glued together. He's got a Dremel tool in there now. And just take it down to the pencil line. Well, what Dave's doing is radiusing off all the edges, evening them up, make sure they're exact mirror images of each other. And while they're glued together like this, you can do your sanding, actually the block sanding on one side. You can get all the edges nice and smooth, so when you go on to the next step, you're working with nice, clean parts. Also, another side benefit of sanding the part thoroughly with 400 or 320 is you'll use a lot less epoxy when you go to join the fuse, the side to the doubler. When that's rough and the body side is rough, you use an awful lot of epoxy, and epoxy is heavy. I've done some with hot stuff, I've done some with epoxy. It seems like they weigh about the same when they're finished. Again, he's got a sanding block here with rough paper, trying to get all the edges smooth, all radiused off nice.
Where'd you get the set of knives?
And this will sand off the little drops of hot stuff. Also, getting a nice smooth surface on this is real important. Two things will happen. You use less glue joining the doubler to the body side. The other thing that's nice about this is you get a nice smooth finish inside the body where the tank is and where the air ducts are going to be. It'll already be pre-sanded. You won't wind up with a messy, rough surface in there. Looking for a place to buy lines.
We were quick to inform him that it wasn't going to matter what he flew next year.
Okay, we have 4 absolutely identical doublers. 2 are going to go on my ship, 2 will go on Dave's. That's going to be it for today. We're going to pick this video up tomorrow. We're going to start making the fuselage crutch. Okay, today we're getting ready to make up the body sides. This is C-grain, 4-inch wide wood. We kind of give it a little squeeze to see which side of the wood is the stiffest. And you notice C-grain wood, how nice and stiff it is. That's what we want for a body side. We take the 2, these are not the 2 lightest pieces, by the way. And we're going to take the old belt sander, he's moving the stuff now. and get a nice straight edge on one edge, and then we're going to reference off of that edge. Also want to make sure, for anybody that doesn't have one of these, it's a little plastic T-square, and there's holes drilled in it that we can just drop a pen line in. You can see all the various holes in there. So once we get the edge on, we're going to use this, drop the pen into the hole, slide it back and forth, and get a center line. We'll show that too. So step one, you have your doubler, you may as well take the nose part first. You're going to be able to get one fuse side without putting a joint in this wood. Obviously, if you have 3-inch wide wood or 36-inch wide wood, you have to put joints in. Again, we got this wood from Lone Star. It's really exceptionally nice wood. You want to get one edge straight. That's the first part of this whole deal.
This ruler's getting twisted.
That rule is not perfectly straight. You got to work off the belt sander. I think Stifle sat on that ruler. We're going to work off the top edge of the fuselage side. We want to get that perfectly true and perfectly straight. And this is one of the easy ways to do it. Obviously, there's other ways. The sanding belts glued to a glass table are a good way to do it.
Where's this guy go? There it is.
Put that back in the pile. We traced out the fuselage shape off of this. You want to get the center line in here, so.
Is this one of the pens we can use for it?
Yeah, this is a real nice fine line pen. I see one of the holes matches up with that. Just do it just exactly where you want it. Okay, that's the center line off our clean edge. Now get your template for the wing cutout. Let's put the wing cutout in there. Remember, we're referenced from the center line to the center line of the template for the wing cutout. Use a nice fine line pen. These are called Sharpies. I don't know. What's the name of these pens? Sharpies? They're real fine point pens. They're not like
Bic
ball.
micro metal.
Micro metal. Spend a few bucks for a decent pen. Then we're going to trace out on here, and we're using a template again. Tail moment arms and fuselage former positions. Which is one of the reasons it's nice to make a plywood template the first time you build a plane. The second time through, you can build a plane in a much shorter amount of time. And Dave's using a straight edge to get all the edges nice and straight. A brand new blade. When you cut against the grain, make several small cuts rather than try to chop right through in one shot. And what we're looking for is all nice straight edges and two mirror image C-grain fuselage sides with one edge, the top edge of the fuselage, as our reference line for all the rest of the alignments on the aeroplane. And once we make one fuselage side, we'll use the first good one actually as a pattern to cut the second one. And we'll do exactly what we did with the doublers. We'll marry them together, make sure they're mirror images of each other. Very important that you start with two parts, two fuse sides that are the same, pretty much mirror images of each other. And whenever you're doing this kind of work, it's a good idea. Use fresh, brand new X-Acto blades. Don't try using up the old ones. Because if you make a bad cut in this piece of wood, It's just one more inaccuracy built into the plane. You like to get these as accurate as possible. Fuse sides are very important to get accurate. Now, a good technique for cutting out the wing cutout nice and accurate is use that plywood, the plywood template that we used. In this case, Dave's using the plywood template that he has from the plane he built the year before. So it's real handy to have these plywood parts when you go to building the plane, the next plane down the road. You know they'll both be accurate. They'll both be either the same, or you'll have some reference if you're shortening the nose, lengthening the nose. If you tend to build heavy, build the nose a little bit longer than it shows on the plans. If you tend to build light, or you're going to put a real light finish on the plane, shorten nose a little bit, 1/4 of an inch, 1/2 inch the most. This way you can kind of custom tailor the design to your own personal needs. My planes tend to be a little heavy, so my nose moments are usually whatever's on the plan are a little longer. Now this plane, we're going to try to make a built-up tail for it, so we're hoping we're not going to wind up with a 4-ounce tail on this guy. In fact, we'll probably make a foam tail and a built-up tail and then use the lighter of the two and give the heavy one to Rick Campbell. Vacuum off the fuse sides too, Dave. The more dust you can get off of this, the less epoxy you'll wind up using. And obviously you want to use the minimum amount of epoxy on this. Both of the fuse sides are sanded with 400 with a block, and all the dust vacuumed off of them. Good idea to get all the dust off the table too when you're working on this operation. Alright, we're ready to epoxy this on. Alright, we're using 5-minute on this. You can use CA and you can use longer drying epoxy, but since we're trying to make some production time on this, CA will be, I guess we could have used CA, but I'd rather use the epoxy. I think the epoxy would be a little bit better. Rub it in like Dave's doing with a trowel. Trowel it in as tight as you can. You don't want a big glob on it. Now use the other doublet. No. Just one at a time, or you're never going to get the thing done in time. You'll never make the time. The epoxy will kick off before you even get it finished. Trowel it right on. Now what Dave has, we'll show this on the camera, is a little piece of plywood with little teeth cut in it so that it leaves little beads of epoxy all over. That's good.
Probably don't need this much.
Well, press the doubler down and then pull it off and see if you have any dry spots. That's the easiest way to do it. Now if you're using slower drying epoxy, you can really take your time here, but right now we want to kind of get this moving along before this kicks off. Let me flip this over. Don't even bother doing that. Don't even bother that. Don't throw the epoxy away because we may have a dry spot on here. Get that mashed down and split it. See, now you can see if you have a dry spot. Hey, you got plenty. Now just get that. You know you have plenty on there. Just work it out in here.
Okay.
Press it up. Get the jar with the alcohol and paper towel so we can clean the table if the first thing doesn't turn into a messy thing. Okay, you got it all. No dry spots at all. That's it. Get all the extra epoxy off before it kicks off. And because this is 5 minute, you can really just smash this down. You don't have to let it dry under weights. If this was slow drying epoxy, you want to get it under some weights. Get it lined up good.
This thing with the teeth in it's a cool trick that Scott Smith does.
Yeah, that's Scotty.
Yeah.
Get it ready for 1 second. You can take a little bit of alcohol and get some of the epoxy off here just to clean it up. And we'll do the other one off camera. Just keep pressing it down. Epoxy's getting ready to kick off. Keep pressing it down for a minute or so. Now one of the things I did here, I like to end the doubler by beveling it down. I don't like to just end a square doubler. Radius that off. That kills off whatever stress riser is in the wood right there. In other words, you want a smooth transition from no doubler to doubler. And I've just ground it down, block sanded it down, or Dremel tooled it down, whatever's the easiest. You don't want to have the doubler just end, because right where it ends there's a stress riser, and that's where it'll try to crack every time from vibration. Okay. Okay, Dave's got the T-square. There's a hole drilled in it at exactly the height we want the wing in the body. Put the center lines on both fuse sides. And then we'll put the fuse sides together and marry them up and make sure we have two identical ones. This is probably the most important part. Remember, we're using the top of the fuselage as a reference for all alignment. We'll align the motor mounts in the fuse crutch. We'll align the wing in there and the tail, all off of that center line. Marry them up, see if they're the same. We have a center line on it.
Looks good.
Make sure we have a straight edge. Just focus in on this. Alright. We're going to make up a crutch. Now obviously you can buy a crutch from ProStun Products or you can make your own. These are matched 1/2 inch mounts. Try to focus in on the grain. The grain is going this way. You can see the lines in the grain going side to side. The lines in the grain go side to side. You want the bolts going top to bottom. That's how you get the most rigidity out of a mount. So I'm marking up both of the mounts so that I have most of the... This is a matched set now. These are cut by John Gajewski. It's a matched set. I want to know which way I'm going to use them. Laying it out on the table, I want to measure the length. First thing is to get the length right. Leave 1/8 of an inch for the plywood nose ring. Okay. Get them centered right in there. Okay, and obviously make sure you make a set. Don't make two individual ones. Marry them up. Make sure you have the countersink part of the mounts on top. The pads. Okay. Now the easiest way to make the whole operation go fast is just get some old CA and actually glue the aluminum with a few drops of CA. This is just going to hold it in place while we're working on it. Glue the pad right down. Get it centered. It's the right distance from the front. All this glue does is hold it on while we're doing a drilling operation. Again, without the pads, the motor sinks into the wood, and after 50 flights, you lose the alignment. All the alignment that you've worked for so long and so hard. Now, before we even drill the motor mount holes, if you buy a set of pads, you get number 2 wood screws with it. We're going to set this up for the wood screws. Go over to the drill press, drill it up. Okay. Of course, it's best to use a drill press. If you have to use a hand drill or an electric drill, try to get it as straight as possible. Okay, and all we did was just start the little holes for the wood screws. Now we'll have the wood screws holding this down, and we'll be ready to drill the holes for the motor mount bolts. We'll tighten this down. We could do that off camera. Dave is using a drill. That's the size of the OD of the 632 bolts to drill a hole. Then we're going to have to countersink the back of the mounts to fit the blind nuts. Now the pads are already on. The pads are precision drilled in a fixture, so they fit the Super Tiger, in this case the Super Tiger 60, very, very accurately. They're not done by eye or by hand. They're done in a fixture in a mill. Now the pads have the pads wood screwed on, they're hot stuffed on, then wood screwed. So everything should be in pretty good alignment when we go to line up the motor. Now a lot of the newer Super Tiger 60s, you have to open up the bolt holes where 632 screws won't go through. And that's one of the steps. I haven't looked at the motor yet. It looks like an old case motor. If it is, you have to run the same drill for the 632 screws down through the motor. .632 head bolts, 632, and blind nuts to mount the 60. No substitute. No copper inserts, no 440 bolts, 632 only on this. Now we're countersinking the back of the mounts for the blind nuts. You just run the drill in about 3/16 of an inch. You don't want to run that hole, that big diameter, all the way through. You want to leave some of the meat on the motor mounts. Try to line it up so all the teeth of the blind nut, all of the teeth are in the wood. They're not hanging out over the edge of the wood. There we go. Okay. Okay, now screw in all the bolts. Make sure all of them are lined up right before we hot stuff it.
Now you want to say you're not building offset into this.
Yeah, now Dave just brought up a good point. If you decide you want to have a straight motor, and if you look at pattern master plans, the motor is in dead straight, well then right now you want to get this motor in perfect alignment. In our case, we want to have a little bit of offset, not a lot, just a little bit, so we can get the nose ring in favoring the outside of the circle. Then what we do when we want to put more offset in is open up the holes in the motor, and this way you can adjust the offset. But my suggestion is you start with a little bit of offset and then get the nose ring in a little bit of offset. This way when you finally wind up with the final adjustment, you don't wind up with a straight nose ring and a crooked motor. Now if you look at some Super Tiger 60s, this side of the motor has a little bit of a burr on the bottom of the mount. So you want to look from the front just like this and see if you don't have this mount crooked because of that little burr. It's a machining error that's in all Super Tiger 60s. And you want to of course have these perfectly parallel and tight. Tighten up on the blind nuts and hot stuff the blind nuts in. And at this point have a little bit of offset to the outside of the circle, and then we'll go ahead with the next step of the crutch. Build up a nice little fillet of CA hot stuff epoxy so those nuts don't come jumping out on you. We got the little bit of offset in there. We've got about 1 degree in this crutch. Use that tri-square and get it parallel now. Show them how you check to see if the mounts are parallel. Of course, you lay the mounts flat on a glass table to make sure you don't have some twist built in. Now, by doing what he's doing, he's walking right down the 2.5 inch line.
It's perfect.
2.5 inches right to the end. And we'll saw off what we don't need after we're finished with the crutch. This is why you need to start with perfect parallel mounts.
Any closer, they'd be wrong.
No, that's pretty good. Okay, you have the nuts hot stuffed in, it's parallel, and the bolts are tight. Now we're going to fill in between the mounts with 1/2 inch wood. Now the whole object of this thing is to get the grain in, get the wood in end grain. That means from mount to mount. Don't do it like they show you on the Magnum plans where it goes front to back. It won't be as effective. Now the way to do this and get a real precision fit, where you almost won't need any glue. Okay, he's marking up where the first piece went. Run it up on the mount and use the mount itself. See, the second mount now is in a precision. You're going to get a precision fit. You score it. All you do is score it with a new X-Acto knife. Then when you saw it, when you go to the saw, you saw on the opposite side of the line. And then block sand it in little by little till you have a precision fit. Okay, it'll be a little bit on the tight side because you left the line on. Now just block sand it in. And you should have 2 or 3 blocks done. You need 3 blocks on there before you can cut it off. Just dress it off till it's a tight fit, and then check that you didn't go over the dimension. You're not bowing it out. Use sanding blocks. Don't sand by hand.
There it is.
Perfect fit. Okay, great. Now what Dave is doing, he mixed a puddle of epoxy and just shoved the end grain down in. Make sure you get as much of the end grain on there as you can. This is a very important step. Shove that glue right down into the end grain. Then we'll put a little bit on the inside of the motor mounts and clamp this together in a vise while it's drying. Now we had to use 3/4 inch wood. We didn't have any good 1/2 inch wood. It really isn't important because we'll sand it all down so it's parallel with the mounts, block sand it down. Now what we have is we have it in the vise. We have some tape holding the end. There's a whole machinist vise you can buy for about $10 in a store. And you can get an old rusty one at a garage sale, it's fine. We have the mounts clamped in. They're dead parallel. We've checked the dimension that we haven't lost our dimension. And just to make sure, we have this taped tight so that it squeezes out some of the extra epoxy. And we're going to let this dry for a few hours. Just let it dry off. Now when we go back after this is all dry, we're going to trim the motor mount bolts and sand down. This is always a good idea to get the extra epoxy off with some alcohol and a rag. Just make our sanding job a little easier later. Again, if you're too lazy to do all this work, you can buy these crutches already made up from ProStone products. Once you have this crutch and straight fuse sides, putting together a body that's in perfect alignment is a piece of cake.
Alright, that's all set.
Alright, we lighten that up a little bit. Don't get carried away if you do this and go right through. Radiused off the back so we don't have a stress riser, and now we'll hog this out for the mounts. For the wing, and we'll be all set. The wing saddle. This is ready to go. Okay, now what we did is we glued one fuse side on. Now we're just getting the alignment on the second one. Now to check the alignment, use the tri-square through the leading edge of the wing on the center line. Get them even, and put a reference point inside the fuselage, which he did.
Okay.
And now we're ready to glue up the second one. Once you have the reference point, you're all set. Now don't forget, you can't the blind nuts have to hang off over the table. So leave it hanging off over the table. And put plenty of glue on there. Don't try to be cheap with the glue. And then the front on this guy is going to get bowed in anyway, so it won't even matter. Okay, you ready? Line nuts off the table. Just that far. Line up that little dot. Okay. Say when. Got it?
When?
Okay. Put a little bit of a squeeze in it. Let that kick off. And all we have to do is clean up this little area here. We've got. Okay. Let's just hit it again before we take it up. Just give that a little squeeze. This way you're squeezing both sides at once. Okay. Now face that at the camera so you can see. Okay, that's where we are right now. The crutch is holding the whole body together. You can see up in the front. Point that front up, Dave, so you can see how we're bending it. We've got a little bit of a curve in the front of the mounts, and we're bending right here. Bending that, we get a little bit of strength from curving that in toward the spinner. Adds a little bit of strength to the nose. Alright, now show how you're going to pinch that. Put a little bit of the slow hot stuff in there, pinch it, and hit it with kicker. Okay. Just pinch the heck out of it. Now what we did, we just glued the back of the two fuselage sides together with a piece of 1/8 inch square in between, and just drop in 3 formers. Grain side to side on the formers, Or if you're working off plans, you can work off the fuselage formers on the plans. This way you just drop them right in. Grain side to side. Now obviously it's not super critical where you have the formers. You just want to get a nice curve and a nice contour to the body side. They should fit with a press fit. And you just put a couple of drops of hot stuff on them, and we'll trim the bottom off later. Look at it through from the front and see if you have the right bow to it. Okay, Dave's permanently gluing in the formers now. Again, you do most of this by eye, just eyeball it up from the front. You can see there's a piece of 1/8 inch square between the two fuse sides. And if it's crooked, you can break, while it's all temporarily glued, just break it loose and re-glue it. Right up to the last minute that you actually carve the block, you can break this loose. You gotta have a feel for doing it by eye, looking at it right down the end. And I like to do the back first, and then I'll work on the nose section. But while the back is nice and stiff like this, it isn't getting broken up every time you make a former. And glue it all in, and then he'll slice off the bottom of the formers. These formers are just hanging out the bottom. We'll show you a little trick to trim them off nice and even. Now the formers are sticking out the bottom of the body. He's just going to take a little machinist rule. Let me get on the other side. Maybe you can see this from the other side. Take a machinist rule and just go right down the machinist rule. Run a block with some sandpaper on it, and you've got all your formers in here in one shot. Now obviously some designs call for more formers, less formers. You can copy formers off of the plans that you're using, but this is one way to do the fuselage formers. Get them pretty right off the bat. Alright, now we're almost at the end of the first tape of this set. On the next tape we're going to do the nose construction, in by the tank box, carving the top block and the cowling, and maybe even get to the rudder on that. This is pretty much near the end of the first tape. There'll probably be some other little information on the back of this tape, but from this point on, this is the basics of the theory of why we do it this way, and how we get up to the point of having the rigid structure. Call this part of the plane the crutch. And from this point on, we'll be working on the cowling, nose construction, the top block, all the parts of the construction that make it an individual aeroplane.
$40mm, huh?
40 millimeters by an inch and a quarter.
Millimeter.
And just touch it with the block till you get the fit that you want. Make sure the grain is side to side, and hopefully that it's sea grain wood or plywood. Now this plane is destined to be a tuned pipe plane, so we're going to have to allow some room up front for the pipe. If you're building a normal engine setup with a tongue muffler or chamber muffler, you won't have to allow anything for the pipe. You can just close in the front, make a normal V deflector. We're going to make almost a modified V deflector here so that we can get the pipe in and out of the plane easy. You get a nice tight fit in there?
That's real good. Say we can glue that in.
Okay.
That's